Our lives are in sync with Earth's rotation. As our planet rotates on its axis, we shift from day to night and warm to cool. As a response, our weather follows a daily cycle. Now, the most detailed view of our daily weather has been created, using a new NASA record that combines almost 20 years of rain and snow. By combining these two satellites, scientists calculated the changes in precipitation every 30 minutes for 2 decades. This is part of NASA's newest extended precipitation record, known as the Integrated Multi-Satellite Retrievals for GPM, or IMERG analysis. From the vantage of space, IMERG shows the 24-hour pulse in weather, known as the diurnal cycle. This cycle helps shape how and when our weather develops, and is fundamental to regulating our climate.
In the case of precipitation, one of the main questions is the different main modes of variability. One mode of variability is a seasonal variation. On a much shorter time scale, the main mode of variability is the so-called diurnal cycle, that is, the variation of precipitation with the day.
IMERG not only shows us how much the rainfall shifts, it tells us what time it shifts and peaks. Over the US, we see a variety of patterns. This shows the average amount of rainfall every 30 minutes during the summer months of June, July, and August. In Florida, heat from the sun builds up over the course of the day, driving rainfall over land. Sea breezes from the Gulf of Mexico and Atlantic Ocean feed the storms over land, driving storms to peak in the afternoon. At night, rainfall moves over the ocean. Storms intensify offshore, only to move inland during the day again. Over the Midwest and the Great Plains, heating over the Rocky Mountains forms storm systems during the day, which then roll eastward overnight. In the US Northeast, heating over land causes rainfall during the day that moves over the ocean at night, because the water doesn't cool down as quickly as over land. Due to this, you can clearly see the warm Gulf Stream water moving past the East Coast on its way to the North Atlantic. During the winter months of December, January, and February along the West Coast, the daily patterns of rainfall every 30 minutes show how the coastal regions generally receive similar amounts of precipitation throughout the day. In the winter, precipitation is driven less from the daily heating of the sun and more from the Pacific Ocean bringing in atmospheric rivers, corridors of intense water vapor in the atmosphere.
So by studying the diurnal variation, this gives us a basic scientific understanding of what the atmosphere is doing, and it prepares us to look at models and understand what the relationship is between rainfall and these other variables like air quality.
Current climate models have difficulty accounting for the diurnal cycle, but the improved detail in IMERG could help fill in the gaps to create a more complete and accurate picture of daily precipitation, not just in the US, but around the world.